Okay, welcome to the 28th session of the flipped classroom for AP Calculus. This is section 3.7, the last section of chapter 3 on Newton's method. Newton's method is just a way to approximate the zeros of a function. Okay, the zeros of a function are the values of x that make that function, or the function value f of x, equals 0. Okay? Sometimes you're not able to do that. You don't have a graphing calculator that can clearly show you what the zeros are. And what Newton's method does is approximates the zeros by doing a repeated operation where you take the tangent line to a function and you find the zeros of the tangent line and keep moving that approximation closer and closer to the actual value that you want. Okay, this will become clear to you as we go through a couple examples. Okay, so what you're looking for is where the tangent lines to f of x, the tangent lines cross the x-axis. That would be a 0 for the tangent line. Let's take a look at a graph on the next slide to see if we can visualize what's going on. Okay, so here we have a graph of some function y equals f of x. That's in red. Okay. I would like to find the 0 at that dot, like to find the value of x that makes that function 0. So the process is I just choose a value that I think might be the 0. Okay, sometimes you just choose it to be 1. It's kind of capricious the way you choose it, but usually 1 is a good starting point. So we choose, let's say that we make x0 our first guess. And what we do is we come up with an equation for the tangent line at x0, okay? That we know how to do because if we can find the derivative of the f of x, and using the point x0, f of x0, we have a point and we have the derivative. So we can find an equation. The equation won't have any numbers, but we can find an equation for this tangent line. Then what we do is we said, okay, I want to find this point, okay, this point where the blue line, which is the tangent line, crosses the x-axis. That will be the 0 of the tangent line. And then we use this value of x and we put it back into the equation for the tangent line at this point, okay? So the green line is now, we're going to find the equation of that tangent line, and lo and behold, this tangent line crosses the x-axis as x2, which is getting closer and closer to our true value. Okay, I would caution you that Newton's method doesn't work for every function. It only works for functions that where these values will converge on the true value of the 0 of f of x. Okay. How does it work? Well, like I said, we choose some point xn, f of xn, on the curve, which would be our guess for the 0 of f of x. The tangent line to that point can be expressed as, y minus f of xn, that's the difference of the y's, okay, equals the slope, the derivative, times the difference of the x's. This would be point slope form. Okay, the next thing we're going to do is we're going to find the 0 of this tangent line. Well, where does the 0 occur? It occurs when y equals 0. So we're going to set y equal to 0. So 0 minus f of xn equals the derivative at x times x minus f of xn. Okay? Now what we're going to do is we're going to solve for x. So x will be equal to xn. Xn is our original guess for the 0, okay, minus f of xn divided by f prime of xn, as long as f prime of xn, of course, doesn't equal 0. This value of x would be the next approximation for the 0 of f of x, which you use the same procedure outlined above to find the next approximation, and so on and so on. You might ask, where do you stop? Okay. Well, this depends on how precise you want to be. Sometimes the problem will say till you get to 4 decimal places. What they mean by that is if you have 2 successive approximations where the 4 decimal places are identical, then you would stop, okay? Or it may just say go through 4 iterations. An iteration is just one time through Newton's method. Go through 4 iterations 4 times and then stop. Okay, you have to read the instructions to the problem. Here's an example. Let's say we've got the function x squared minus 2 equals 0. Okay, now this would be easy to find the 0, so it would be plus or minus the square root of 2, but let's just make a guess. Let's say we guess that x equals 1 is a root of this function. In other words, it makes f of x equal to 0. Apply Newton's method. Well, okay. X would equal xn minus f of xn divided by f prime of xn. That's from the previous slide. Xn is our guess, so that's 1. F of xn, by putting 1 into the original equation, equals negative 1. Find the derivative. F prime of x would be 2x. Okay. The next thing I would do is set up a table similar to the one on the next slide. Okay. So this is the number of times we've gone through. Okay, xn is our original guess. This is the function value. This is the derivative value. This is x, the n plus 1. Okay, that's the next guess. Okay, notice we come out with the 1.5. It becomes the next guess on the second iteration of Newton's method. Okay, so when I put 1 in here, like I said, I get negative 1 for the function value. I get 2 for the derivative. Remember, the derivative is 2x. And using this equation, x to the n, 1 minus f of x at negative 1 over 2, I get 1.5. Sticking the 1.5 in is my next guess, calculating the function value at 1.5, calculating the derivative at 1.5, x to the n plus 1 would be this equation. I get 1.41166. Doing it again, okay, and the third time, notice, here I have 4 digits that are exactly the same. 1.414, 1.414. Actually, I have 4 digits after the decimal point that are the same. I'm sorry, 4142, 4142. We could stop there if our direction said to go to 4 decimal places. Okay, notice that we already knew that the root of this, at least one of the roots, was the square root of 2. Okay, square root of 2 is very close to this, so this would be a root for this function. Okay, the question becomes, how would you get the other root, which would be negative root 2? I would suggest that you try negative 1 and see what happens. For homework, I want you to try page 323, 324 slash 1 through numbers 1 through 12 and 15 through 17. You should get used to doing these calculations, but it is possible to set up a spreadsheet where the spreadsheet automatically calculates Newton's methods for you. Okay, I'll show you that in class. If I forget, remind me. Okay. All right. This should be fairly simple. Please start to work on it as soon as possible. Thank you.